This is number 7 from the summer assignment, the first summer assignment practice test. This problem is a polynomial. The first thing I do with these is try to see if I can factor. Generally, factoring is the fastest way to go about solving. This one, since we have x to the 5th, we can't really factor. We can't factor by grouping. I don't see anything that we can factor out. So we want to graph your polynomial first. When you graph it in your graphing calculator, what you'll see is that your graph crosses the x-axis at -2. And once you find that, you can synthetically divide. So we're going to use synthetic division to show that -2 is, we're going to use synthetic division to show that -2 is a root, but also to find a smaller polynomial that we can work with to find the other roots. Because if you look at the graph, -2 is the only root that you can see on the graph, which means our other roots are imaginary. So when we synthetically divide by -2, we just pull down our coefficients, the numbers in front of our x's. Remember, if you have any gaps, like if you were missing x squared, you would need to put a 0 in there. That doesn't happen on this problem, but it happens pretty frequently. I like to put a little dotted line in front of my 48. That should be a 0 if I should come up with a 0 remainder if -2 is a root. So we pull down our 1, multiply -2 times 1, we multiply here, get -2, and then add vertically. We have a 0 there. Again, multiply, add, multiply, add, multiply -2 times 0 is 0, add, last one, multiply -2 times 24 is -48. 48 plus -48 is 0. So again, we've done two things. We've verified that -2 is indeed a root, and we've gotten a smaller polynomial out. Since we started with x to the 5th, the polynomial that we get out here is going to be x to the 4th. So this is 1x to the 4th plus 0x cubed plus 11x squared plus 0x plus 24, and I'm going to set that equal to 0. From here, we can't do synthetic division again since we don't have any other roots that we don't have any other roots from our graph to look at. So we can't do synthetic division again, but what we can do at this point, if we had a squared, we could factor, but we don't have a squared, so we want to, if we have a squared, we could do the quadratic formula. Since we don't have a squared, we want to see if we can factor. So we have x to the 4th, x squared, and 24 here. I'm going to do this on the next page. So our factoring situation looks like this. And what you can see here is we want to find two numbers that multiply to 24 and add to 11. Since we don't have a leading coefficient, you don't have to split the middle. Those two numbers are 8 and 3. And since we have x to the 4th here in front, instead of just an x, these are going to be x squareds. And now we can just set both these equal to 0. So here I have x squared equals -8. Take the square root of both sides. That gives me x equals plus or minus square root of -8. 8 we can break down. 8 is 4 times 2. Square root of 4 is 2. So square root of 4 is 2, so I can bring a 2 out. I have a 2 under the radical. And this negative under the radical becomes an I on the outside. So two of my imaginary roots, which always happen in pairs if you'll remember, our plus minus 2i radical 2. Over here with the 3, similarly, but we can't break this one down, we get x equals plus minus I radical 3. And remember, you also had that x equals negative 2. So we had an x to the 5th, and we have 5 roots here because of our plus minuses.
Made with Doodlecast Pro.